a few more comments on what we mean by this word topological density, or topologically dense adjective, in red. Okay, in 1, 2, 3, 4 relatively short statements. First statement is that every constructed point lies at a distance p over 2 to the n plus 1 times the circumference along the arc for some integers n and p. Now that's really, kind of you ought to try to digest that statement and see if you can make sense of it. If you can, you're doing extremely well. But I'm going to go ahead and explain it now. So that's kind of a spoiler alert. Don't let it get spoiled for you before you think about it. Okay. If we divide the circle into 16 arcs, that's 1, 2, 3, 4, and so forth. Well, that's 2 to the 4th, right? So 16 is 1 over 2 to the 4th times the distance around, or 1/16 the distance around. And I don't know if I said that whole sentence correctly. There are 16 subdivisions around here, 16 positions on the circle. So each position lies, the first position lies at 1/16 the entire circumference from our standard starting point, which is along the positive horizontal axis to the right of the origin. Okay, so there's 1/16, right? Well, then how far is this? You might say 1/8, you'd be right, but I'm going to say it's 2/16. Worry about reduction later. Okay, and then we have this point at 3/16, 4/16, and yes, I know that's 1/4, and so forth, all the way around to 15/16. Okay, so I can say that every constructed point lies at distance p over 2 to the n plus 1 times the circumference. How can I say that? Well, in the case of n equals 16, in the case of, let's say, this point, this lies at a certain number of 16ths. Okay, turns out to be 12/16, yes, 3/4, 12/16, 3/4. What am I thinking? I'm thinking 12/32. I'm sorry, 3/16 of the total arc. Okay, so P would be 3. N would be what? N would be 2. And I say 2 to the n plus 1. It should be 2 to the n plus 2, shouldn't it? Okay, because I'm using n plus 2. So if n equals 2, 2 to the n plus 2 is 16. So for n equals 2 and p equals 3, we get 3 over 2 to the 2 plus 2, 2 to the 4th, 16. 3/16 of the circumference. That's this point. Okay? Every point that we can ever construct, any point anywhere that can be constructed, has to be constructible by first dividing the circle into 2 to the n plus 2 for some value of n. And of course I'll put some dotted lines here. These numbers can just go on forever. For some value of n. If it can be constructed, there's a value of n such that we can divide, such that we've divided the circle into 2 to the n plus 2 parts, or divided the arc equally into 2 to the n plus 2 smaller arcs. And then we're at some number of those divisions around the circle. The number of those divisions we have, or the number of those little arcs around the circle that it takes to get to a point, is the value of P. The number of divisions, the number of times we need to iterate our division is n. Okay, so every constructed point lies at distance p over 2 to the n plus 2 times the circumference. See if you can write that out and say it a little more clearly than I just did. Okay, second statement is points at distances 1/3 of the circumference, square root of 2 over 2 times the circumference, even pi over 4 times the circumference. We know that pi is closely related to the idea of the circumference of the circle, and of course 4, number of quadrants we have here, but even something like pi over 4 times the circumference. We can't do it. We can't construct any of these distances. based on our circle, just by subdividing in any way. No matter how we think we can perform a subdivision, it isn't going to work. You can't do this. Now, I've mentioned Galois theory before. Galois theory tells us we can't, but Galois theory is way, way deep, and we can't talk about it. But it's provable that you can't construct these distances in this manner with compass and straight edge. Okay, so there are points on this circle that are not constructible. However, there are infinitely many constructed points near any of these. Now, any of these means this point, or this arc, or this arc, or this arc. Okay, and I should say constructed arcs near any of these, but I'll stick with points. And by infinitely many constructed points near any of these, what do I mean? It means even if this point isn't constructible, I can keep increasing n and increasing the number of little arcs. Okay, so if I go to n equals 10, I get 2 to the n equals 20, I get 2 to the 22nd. That's over 4 million. I'd have 4 million points around here, and they're all equally spaced, so that I would be within easily 1/4 millionth of the distance from this point, even if this point isn't constructible. Okay, and then there are infinitely many more points, because between any two constructible points, I can construct a point, and I can keep constructing points between those points, and I'll have infinitely many points within 1/1 millionth of an arc of whatever this point is here. Okay, so that is kind of a mind-blowing idea, and if you haven't thought about it, it's worth stopping to think about, try to write it out, try to make sense of it for yourself. But there are infinitely many constructed arcs near any of these, no matter how near you mean by near. Okay, so no matter how near you mean by near, if you mean 1/4 millionth, then just let n equal 20. And you'll have at least one point that's that close. And that means you're going to have one point on each side. You get 1 point on each side that are only 1/4 millionth of a unit apart. And then you can start subdividing that interval as many times as you wish, infinitely many times, or your number of times approaches infinity. So there'll be infinitely many constructed points, no matter how near you mean by near. If you want to go 4 trillionth, well then, let n equal 40. And then any n greater than 40 is going to give you additional points within that proximity. Okay, this is what we mean by dense. It's hard to get your mind around just how dense is, and it's also hard to get your mind around the fact that there aren't points that are included among this infinitely dense set of points. But it actually turns out that in a very important mathematical sense, there are more points that you can't construct than that you can.